Good afternoon, everyone. I'm Dr. Daniel Barth, and welcome to another episode of the How Do You Know program. This is episode 81, and we're going to help you prepare to enjoy October's annular eclipse.
Live programming at its best, isn't it?
That's right, live programming. As always, the How Do You Know show is brought to you by Explore Scientific, who sponsors us here. We're in the Explore studios today, and by the Star Mentor book. Are you a novice astronomer?
Oh, there, on the screen.
You okay?
Yeah.
Good man.
I'm goofing around.
Are you a novice astronomer, friends? Are you thinking about getting a first telescope this holiday season for someone special? Are you worried about getting a telescope and then having your loved one say, but what do I do now that I've seen the moon? Wouldn't it be nice to have a professional astronomer right there with you to help every step of the way? I wrote Star Mentor just for you, a series of activities and other guidance to help you learn how to operate your telescope, learn to read a star map, learn about the sky, the constellations, star hopping, and learning about what you're looking at. And if you're an experienced astronomer and you have others who are asking you, teach me, Star Mentor is also for you. It's very readable and it's designed to be gone through a la carte. You can choose what activities interest you most, and each one gives you full guidance, plenty of illustrations, over 180 illustrations in Star Mentor to guide you to becoming a better astronomer. Now, let's talk about the science news. Several interesting things this week. One, scientists are looking at last year's Hunga volcano in the South Seas and the Antarctic ozone hole. It turns out that Hunga, and I had to read this twice, I was just like, oh my gosh, it injected 50 megatons, 50 million metric tons of water. Consider that it takes about 10 metric tons of water to fill a 24-foot by 4-foot deep swimming pool, one of those 24-foot round by 4 deep swimming pools you see in the backyard. That's 10 tons of water. We're talking 50 million tons of water injected all the way into the stratosphere.
So you can
As
do
you
the
might
math.
imagine,
You can do the
this
math,
sort of
and that's 8 pounds a gallon, right?
yes, 8 pounds
So-
a gallon.
So you do the 50 million or whatever it is, divide by 8.
A metric ton is approximately 2,200 pounds. So multiply 50 million by 2,200, and you'll get the American weight of water in pounds. You know, the metric scale. This is for my producer Paul. The metric scale goes all the way up, kilo, mega, giga, and somewhere it becomes lotsa.
Well, we're
That's an old science
Americans,
teacher
so
joke.
we don't use the metrics.
50 million tons, no matter what your measurement system, is a lot of water. And we wouldn't be surprised that this much water affects the chemistry of the stratosphere. Water, of course, is a solvent. It helps speed and facilitate chemical reactions, and scientists are reporting that they're expecting the ozone hole in the Antarctic, which is a seasonal thing, happens every year, has for millennia, but this seasonal hole should be appearing earlier this year, and they are predicting that it will last longer. Once again, the data will show how good our theories are, but we'll keep an eye on that. The other thing that I just saw, and it's just kind of like, this is so much fun, the professional physics community worldwide is now actively discussing how do we fight flat Earth theory. And I can't really say flat Earth theory. I can seriously say flat Earth conspiracy, because no theory ignores facts, just left, right, and center like flat Earth does. And
Have you ever met a politician?
yes, yes. And politics and science is a volatile mixture. I'll grant you that, my friend. But what we're looking at here is there used to be some idea that, only stupid people believe in flat Earth, but that's not true anymore. Flat Earth is, sadly, and I weep for my nation, flat Earth is very much an American or predominantly an American phenomenon. You don't find large flat Earth community people in other parts of the world like you do here. But the idea that it's just, the ignorant and science deniers, no. And we're finding that people, and attribute this to news media, social media, whatever you will, a lot more people are distrusting institutions, professional scientists, and hey, look at the silliness with we have the bodies of aliens. Honestly. There's a lot of distrust of professional institutions, science included. And on a bet from a friend, I went and looked in social media, and I just checked Facebook, and I looked up teaching flat Earth in groups. There were more than 50 of them on Facebook. Groups of educators who should know better, because if they're teaching science, I'm sorry, what's going on here? And these people are sharing lesson plans and curriculum and teach the controversy and all sorts of nonsense. I have no problem. This show is all about exploring the bleeding edge of science, looking at the controversies in science, looking in places where the theories aren't quite doing the job. They don't explain all the data. And we bring this to you every week, and we tell you the data, we tell you the theories brought forth by, I hope every time, reputable scientists. And we talk about how theories succeed, how they fail, how data reinforces or tears these ideas down. We've talked about the idea that theories go into the cage and basically it's a grudge match. Other scientists will try to tear it apart because knocking someone else's theory down gets you almost as much drama and funding as proving your theory correct. And proving your theory correct or finding supporting evidence for it is a much harder task. But we've got to do better in schools, my friends. As a person who has been a physics and astronomy educator most of my adult life, I retired from education this year with 44 years in the classroom teaching astronomy and physics from high school to college to university level. We've got to do better. We've got to do better. On the other hand, in hooray science news, you probably saw this. It was all over the place. The OSIRIS-REx probe dropped off its sample container from the asteroid Bennu, and it landed safely in the American Southwest, and it's been collected intact. You may remember a few years ago, we had a probe with samples that crash landed and burst apart. They were still able to get good data from that, but we're particularly excited from the stuff from asteroid Bennu. You may remember the idea, we had a probe, which was basically an arm. It came down, and when it hit the ground, it was supposed to release a spurt of nitrogen gas, and the idea was, in the low gravity environment, it would blow up dust and small particles, and we hope to capture 50 to 150 grams. Actually, Bennu is a rubble pile asteroid. We didn't realize this. The sampling arm sank more than half a meter, almost 2 feet, into the surface of this rubble pile asteroid. And when the nitrogen gas went off, it filled the container so full they had trouble closing it. So we've got a great sample, and it's been returned safely to Earth, which is very exciting. And don't look for news about this next week. The research work on this sample is going to be slow and painstaking. And of course, NASA and other agencies involved are going to be dividing up the spoils. Think of a bunch of kids who pile all their Halloween candy on the floor, and then they take turns picking. And, the Snicker bars and stuff go first, and the peanut butter toffees go last. And I don't know how that's going to work with the asteroid Bennu samples, but be assured that dozens of agencies around the world are saying, please, me, trick or treat, we want a sample. And of course, samples will be delivered to labs worldwide. They have to open this thing up in a clean room. They have to take extreme precautions to make sure in Earth's dirty environment full of atmosphere and other crazy stuff that they don't contaminate the samples. So it's going to be long and painstaking, figuring out what's there, dividing it up, deciding which agency gets what, because not every agency is interested in the same research topic. So just collecting and sorting and dividing the samples among the agencies that get a piece is going to be a time-intensive endeavor. But we should be seeing data coming out from this for years to come. Trust me when I say, and I'll make this prediction right now, 20 years after I'm gone, if I live another 20 years after that, people will still be looking at these samples and they'll still be looking at the data from asteroid Bennu and the OSIRIS-REx mission. How do I know? Well, they're still coming out with new research on the Apollo rocks from the 1960s and early 70s. Why is new information still coming out of these rocks and these samples from the moon? Because we have better instrumentation now than we had 50 years ago. And they're going to archive some of this sample and save it for future scientists. Scientists who may not even be born yet, they're going to have a legacy waiting for them from the OSIRIS-REx mission and asteroid Bennu. So more to come, more to come. We also want to let you know that Explore is also working on its CPO program, the Certified Pre-Owned program, and we're working to get that up and running as soon as possible. So this fall and on into the future, you'll be able to contact the nice folks at Explore and ask them, gee, do you have any CPO bargains? And trust me, we're preparing everything from eyepieces to mounts to tripods, binoculars, full-on telescope systems, and we're working hard to get those materials all ready for you. So let's go on and talk about the annular eclipse. What's special about an annular eclipse? Well, an annular eclipse happens when the moon's apparent diameter is not large enough to completely cover the sun. Now, when we talk about an apparent diameter, keep in mind that anything that's round, if it's farther away from you, it appears smaller. If it's closer to you, it appears larger. If you've ever played volleyball or soccer, you know what I'm talking about. When the ball is coming towards you, it looks like it's getting bigger and bigger as it approaches. This is the idea of apparent diameter. Now, the moon and the sun from Earth both have an apparent diameter of about 1/2 degree. However, when the moon's apparent diameter isn't big enough to completely cover the sun's disk, then we don't get a total eclipse, but something we call the ring of fire. If you're lucky enough to see totality along the path of an annular eclipse, it'll never go completely dark, but you'll have this beautiful, brilliant, fiery ring surrounding an inky black disk, and this is an annular eclipse. And people have, when I was talking to people about this show, they said, oh, but those are really rare. As it turns out, no, they're not. Annular eclipses and total eclipses often occur in pairs, and they're just as common. One is as common as the other. Over the last 25 years, we've had 36 solar eclipses, 18 total and 18 annular. So they're split about 50-50. And only 4 of the eclipses in the last 4 years of the last 25 have had no solar eclipses. And you might say, well, if there's a solar eclipse every year, how come I don't hear about them and see them more often? Well, there's no guarantee of where the path of totality is going to go. You can predict, but the Earth is 78% covered by oceans, which means about 3/4 of the time the solar eclipse path is out to sea, which is great if you're a yacht owner or if you're able to afford an eclipse. And yes, they do have eclipse tours for solar eclipses at sea, and you can get on one of these boats. And I was asked one time by a cruise ship company if I would come. Oh, you can have a free cruise, and you can go on board and explain the eclipse to our passengers. And I declined that. But anyway, we'll be looking forward to this.
Hey, Dr. Barth.
Sir.
John Ray and Natalie Davis Olson have said hello.
Natalie, John, great to have you with us today. And thanks for searching out a reputable and legitimate source for your science news content. We appreciate you greatly. So, people say, when you say, Doc, the moon's not big enough to cover the whole disk of the sun, and we've talked about apparent diameter, why does it change? Isn't it always the moon? Well, the thing about supermoon and minimoon, this has become a much more popular thing of late, and the idea of annular eclipse and total eclipse is very much in tune and related to the idea of supermoon and minimoon. The moon's orbit is quite elliptical. That's to say, it's not so much round as it is, favorite word from one of my science teacher candidates, it's more ovally. Yeah. Elliptical is the technical term, my friends. And we talk about an ellipse has eccentricity. How stretched out is that ellipse? Low eccentricity means it's very close to circular. High eccentricity means the elliptical orbit is very stretched indeed. And it turns out that the Earth-Moon distance from supermoon to minimoon, from closest approach to farthest approach, the apparent diameter of the moon varies by about 14%. That's quite a bit. And when we talk about this and we look at the lunar orbit, we refer to the closest approach of the moon to the Earth as perigee, and the greatest distance between Earth and moon as apogee. You can think of it this way. Perigee, P means pretty close. Apogee, A means far away. Now, when we look at apogee and perigee, it changes by quite a bit, and the distance varies about 14%, which is quite enormous, actually. The Earth's orbit is also elliptical, but it has a much lower eccentricity. The Earth's distance to the sun changes by only about 3% from maximum to minimum. Now, the idea of these apogee and perigee points for the moon, why don't we have an eclipse every month? Well, it turns out that the moon's orbit is tilted relative to the Earth's orbital plane by about 5 degrees. So sometimes when we have a new moon, which is what's required for an eclipse, sometimes the moon is above the Earth's orbital plane, sometimes it's below. Only when the new moon lines up in the orbital plane. We refer to that as the moon crossing a node. Only then do we get a solar eclipse. So for a solar eclipse, we have to have the sun and the moon and the Earth. The moon lies between the Earth and sun. That can only happen at new moon. So if new moon occurs at perigee or near it, the moon is plenty large enough to cover the sun's disk. We get a total eclipse, which we will have next year in April. But if at new moon, the moon is closer to the apogee point, the moon's apparent diameter will be about 14% smaller and not large enough to cover the sun's disk. And so we will get, as we do in October, an annular eclipse.
Dr.
Very
Barth.
exciting. Sir.
So I have a question.
Yes, sir.
And the question is, how do we explain the optical illusion that happens at dusk and dawn of the moon getting huge? Because some people may be confused. They say, well, isn't it closer then? It's got to be bigger.
Ah, I see. This is a very common question. So Paul's asking us about the idea of the moon appearing very large on the horizon when it first rises or sets. And that's a very common thing. It turns out there are actually two contributory factors going on here, two things at once. One is, if you think about the Earth's atmosphere is a layer wrapped around a sphere. When we're looking at the moon and the horizon, we're seeing the moon through the most curved portion of the Earth's atmosphere. And so that curvature gives us a magnifying effect that makes the moon appear a bit bigger. The other thing that happens is near the horizon, we're much more apt to see the moon in relation to distant objects like a tree or a building or a mountain. And when we compare, we don't have any sense of reference for, gee, what's the apparent diameter of that tree on a hill 2 miles away that I can see? Wow, the moon looks gigantic next to that. Well, when we see the apparent diameter of a house, we look at the house far away and we know about how big it is. So we don't worry about its apparent diameter. We recognize this is a house, this is a tree, it's about this big. But when it comes to the moon, we don't have any close-up reference points like we do with a house or a tree or a telephone pole. And so if we think about that, these two things, one, comparing the moon's disk to a distant object, which appears small because it's on the horizon, and the curvature of the Earth's atmosphere acting as a magnifier. The other thing about the moon on the horizon, it often looks more yellow, perhaps even orange or red when it's on the horizon, and then the color seems to fade away as the moon rises and it becomes more silvery white. What we're doing here is, again, it has to do with the atmosphere. When we look at the moon straight up, we're only looking through about 100 kilometers of atmosphere, where when we look at the horizon, we're looking through more than 1,000 kilometers of atmosphere. And in fact, it's dust in the atmosphere which filters out the short wavelength light. Dust in the atmosphere tends to extinguish blue, green, yellow colors, and it leaves only the red and the orange. And so as when we're seeing the moon on the horizon, that light is coming through a lot more atmosphere, and hence it has the possibility of coming through a lot more dust. And so the moon appears much more yellow-orange on the horizon, and as it rises, it appears more silvery. When I lived in California and taught there, I had a chance to observe moonrise and moonset over the Pacific a number of times. And looking over the Pacific, unless there's a great deal of wind from the desert blowing dusty air out to sea, the air tends to be much clearer. And so we would get very little color change of the moon on the horizon as it set over the Pacific. On the other hand, here in the Midwest where I am now, we're in farm country, and hey, this is harvest time for a lot of farmers, and so there's a lot more dust and particulates in the air, and so we tend to get more spectacular sunrises and sunsets and a more spectacularly colored moon.
Dr. Barr.
Sir.
So one of the interesting things as a video maker and a photographer, if you try to take a picture of that giant moon and you click the shutter button and it takes a picture,
right,
that moon is not big anymore.
Nope.
So
much of this.
How does that happen?
Producer Paul is quite correct. Much of this is an optical illusion.
Yep.
You've got the slight magnifying effect of the curvature of the Earth's atmosphere, but you also have
the focus of our eyes too. Does
yes, you're talking about looking at a very bright object along a dark foreground and a substantially dark sky, and the very bright object, our eye is drawn to it and it focuses on it, and so we tend to narrow our cone of vision with intense concentration, so we're not paying attention to the peripheral, and so we're seeing it that big. I often did an activity where I would have a variety of balls on a table. I would have a basketball and a 16-inch softball and a baseball and a tennis ball and a golf ball and a marble and a pea and an aspirin. And I would ask my students when we were observing, okay, which object at arm's length is about the right diameter, the same diameter as the moon? Many people would pick a golf ball or a tennis ball. Some people picked a volleyball, and actually an aspirin tablet at arm's length is actually larger than the apparent diameter of the moon. It's about twice. An aspirin tablet at arm's length is about 1 degree for most adults, and that's significantly larger than the moon's disk. And people would say, but wait, I don't get it, because I can look at the moon and I can see Maria, I can see the light and the dark marks, I can see the impact features, I can see all these. How can I see this if it's so small? Your vision is really quite miraculous, my friends.
Yeah.
And being able to focus in and concentrate on small detail, it's amazing how much you can see with your naked eye.
Natalie Davis Olson asked, she just posted the comment supermoon. I think she's wanting to know what defines a supermoon.
Okay. Supermoon, Natalie, occurs when we are looking at a full moon at perigee. A full moon at perigee will look about 14% larger than a full moon at apogee. Now, Natalie, if you're going to observe this, you're going to have to be a very accurate and conscientious observer to see the difference, because a change of 14%, although it's significant, we're still talking an object which is very tiny in our field of vision. So it goes 14%, but the increase in brightness is more substantial than that, because area is a square function of diameter. So the supermoon is substantially brighter. And if you were to take a camera, Natalie, and you had the same lens, the same focus, the same place, and you were to say, ooh, it's supermoon, and go out and capture a photo, and then go out some months later, if you follow astronomy news and you see mini moon, and you can look these things up. When's the next supermoon? When's the next mini moon? Our friend Google, or whatever search engine you prefer, will give you a list of dates easily enough. If you took the two pictures with the same camera, same lens, same focus, and make sure the moon is basically at about the same altitude, you would be able to compare the two photos and go, obviously, oh yes, this one's bigger, that one's smaller. But it is the brightness that changes more than the apparent size. And it's been a thing in the news the last few years, and it occurs on full moon nights, which is kind of interesting, because on full moon nights, a lot of astronomers bemoan full moon nights. The full moon is so bright, it washes out galaxies, it washes out nebula, it washes out a lot of the fainter stars, and makes it hard to observe. But I say, lemons, hello, lemonade. When the full moon is up, let's explore the moon. And there's many wonderful things we can observe at full moon. And since we're coming up on a new moon, we're going to look on the October 14th, the following full moon about 2 weeks later, around the 21st. I'll be doing a show before then telling you how to observe the full moon and what fun things you can look at, because there's things you can see at full moon that you can see at virtually no other time. So we'll go ahead and take a look at that as we go. So now, let's talk about preparing to observe your eclipse. First of all, friends, hands down, first thing, last thing, middle thing, safety first, safety last, safely always. You only get 2 Mark 1 eyeballs if you're lucky, and they're irreplaceable, so we must protect them. And An annular eclipse is not safe to look at with your naked eye at any time. No, no, no. And it's lots of fun, and it gets quite dim, and you go, oh, it's getting dimmer. I can look now. No, 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 no. The sun puts out a lot of ultraviolet light that can burn your retina, and you can damage your eyesight permanently. The retina has no pain sensors, so you're not going to look and go, oh, it doesn't hurt, I'm okay. No, you're not. So what do you need to observe safely? We've got some here. These are sun catcher solar eclipse glasses from our friends at Explore. They were nice enough to loan me a couple of pair for the show today. And no, all eclipse glasses are not created equal. The ones from Explore, these folks have taken the time to get solar film. They make their own. They got solar film, which has been tested and certified. It blocks out 99.999% of the light. It cuts the UV. It makes it perfectly safe. But you must have protection over your eyes. Now, if you wear glasses like I do, hey, that's a great look, isn't it? You can actually put the solar eclipse glasses right over your eyeglasses, and they're quite comfortable. They weigh almost nothing, and they work wonderfully well. If you're observing, you might think, oh, an eclipse, what a great family event. And it is. But if you're observing with youngsters, you must stress to them and you must supervise them. We have to take care. If you're using optics, like a telescope or a pair of binoculars, there are on the market, unfortunately, unsafe products. And when you look at optics, the thing is, you always want the solar eclipse filter in front of any optics. Here's the optics in front of my eyes that help focus the light for me. I'm wearing solar eclipse glasses in front of them.
Dr.
I'm
Barth?
rejecting all the sun's energy before it hits the optical train. If you have a binocular, if you have a telescope, here's one of the big sun catcher solar filters from Explore. And this bad boy uses the same solar film, and these are made custom here in our shop. So if you have a telescope with any particular size objective, you can call up. The nice people in sales will help you get the right size Eclipse sun catcher solar filter for you.
Dr. Barth.
And question?
John Ray, he has a lunar filter that he puts in his eyepiece.
Oh, yes. Oh, my gosh. John, please leave that at home on Solar Eclipse Day. It's not satisfactory. It's not sufficient. The other problem, John, think of the light coming down. I'm not sure what size telescope you have. Let's say you have a 100 millimeter. That's a common size refractor, a small refractor. If you put a filter on the eyepiece, you're catching all that light from your 100 millimeter telescope, and you're focusing all the light and, importantly, all the heat on that filter.
Well, not necessarily does John not know that, but if anybody's paying attention to the chat, they may think that they could put a filter in between, which happens. They sell those, and that's dangerous. You should not use those.
Yes, you can still buy them today. Don't, for goodness sake, but you can still go and find screw-in eyepiece solar filters. These crack. The heat will heat up and crack the glass. Once the glass cracks or shatters, you're staring at an intensified image of the sun. This will damage your image, your eyesight, and even blind you before you can pull your head away.
Yeah, John is saying he only uses his for lunar observations on nothing else.
Thank you, John. Thank you, John. And that's if you're observing the moon, planets, nebula, a screw-in eyepiece for your solar filter is perfectly appropriate. And because the eyepiece filter is much smaller than something like this guy here, they're relatively affordable. But no, we must cut that light energy before it enters the telescope, the binocular, the camera, and most crucially, before it enters our eye. The other thing about the solar eclipse is essentially the moon's shadow, the dark portion of the shadow called the umbra, is shaped like a cone. And because the moon is at just about the perfect distance to cover the disk of the sun, the moon's shadow tapers down until it's only, on a total eclipse, it averages only about 50 kilometers wide, the shadow of totality. On an annular eclipse, of course, that cone is so short it never reaches the Earth. And so you can't be in the cone of totality, the umbra, if you're standing on the surface of the Earth. Nevertheless, the path of the eclipse is never more than about 100 kilometers wide. And so if you're planning on observing that exciting ring of fire, unless you're very lucky and happen to live in a town or a location that's along the line of that eclipse, you won't see the ring of fire. You probably have to plan some travel. A lot of folks here at Explore are planning to go down to Texas next month to observe the ring of fire and do some traveling. Also, keep in mind to keep your travel plans flexible because weather and clouds are not your friend. The last total eclipse in 2017, my family and I planned to go. I had my son, my daughter-in-law, my grandkids, my wife. Grandpa, we're going to get to see a solar eclipse. Yes, we ended up not driving about 2 hours, but almost 6 because we were clouded out in our first choice observation point. So we had to keep driving until we found clear weather. Fortunately, it worked for us. It worked for my son and his wife and their kids, and everybody was really excited. You can look this up again online and find out exactly what time. The other idea to remember is that path of totality is going to pass over an area and it's not going to last very long. If you're going to see the ring of fire, it's going to last at the most a minute or two. And so you need to know exactly when the eclipse is going to occur and be set up well in advance. Now, the time it takes for the moon to move over and completely cover the sun from the first contact to the full eclipse to last contact, that can last a couple of hours. But if you want to see that totality event, the Ring of Fire this October, it's going to be a very specific time and you need to be aware and observe. You must do a little research online to find out when it's going to happen for you. If you put into your search engine, Great American Eclipse, they'll have it. NASA has pages dedicated to the eclipse. It's easy to search online and find an eclipse map. If you're not along that line, don't despair. You can still see a partial eclipse, which is really exciting, and you can photograph it. Again, you can observe it as long as you have proper solar eye protection. Now, what if you don't have solar filter protection? And by the way, friends and neighbors, if you are planning on ordering these products from Explore or any other manufacturer, for heaven's sakes, two things. One, make sure you've got a reputable manufacturer of solar filters that has certified filter material that will protect your eyes. And secondly, get your order in right now. Last solar eclipse, 2017, my friends here at Explore tell me that they were reaching peaks of 30 to 40,000 orders a day as it got close to eclipse time. Guess what? A lot of people were disappointed. Why can't I get my eclipse classes? It's a week to go. I thought, nope. There's lots of people who are fans. They worship at the temple of the last minute. Don't let this be you. Order your eclipse classes now. They're very affordable. They cost very little, but get your order in now. We're packing up and shipping out hundreds and thousands of these every day. Don't be disappointed. And if you want one of these made for you, get your order in right away because these are custom made for you. So they fit your scope and you want to make sure you get yours right away. So like we said, when we talk about observing the solar eclipse, some people also have the idea, oh, I can get a picture of the solar eclipse with my camera. Yes, you can. However, if you're talking about a camera, one of the nice things is that most quality cameras, and even a cell phone today, you can look at your camera and you can adjust your settings to where you can get the exposure time short enough, thousandths of a second or even less, to where you can take a photo without damaging your optics. However, I guarantee you, if you've got your exposure set, quarter second, half second, second, and you've got a nice lens on your camera, your expensive DSLR, just like the unfiltered sun can burn out your retina, you can also burn out the sensor on your camera or your cell phone. So please, if you're going to try to take an image of the eclipse, one of the things you're going to want to be doing is zooming in so that your image of the eclipse fills the sensor and gives you a nice big image. But doing that focuses a lot of energy on your camera sensor. So do some practicing, look up online, check on what kind of camera you've got, whether it's a cell phone or a nice DSLR or a point and shoot, and check about the sensor. If you look up, how do I photograph the eclipse with my Zowie Wowie 5000 digital camera or my Electro 7000 cell phone? If you look online, you can probably find some good information from user groups or manufacturers so that you do it safely. There is another way to observe the eclipse that's cheap as free. Did you know you can observe any eclipse safely under a tree? It's astounding, but trees function as pinhole cameras. What's a pinhole camera? If we took a piece of paper and we took a pen and we poked a small hole in it and we held it up in front of the sun, well, guess what? We're going to, at a distance of about 30 centimeters or so, we're going to project a nice image of the sun's disk. Why do the dapples of sunlight under a tree always appear round? Because they're all actually images of the sun. As you watch the moon's disk cover the sun, you're going to see these round dapples, first with a bite cut out of them, and later they'll appear as crescents of light. Even if you don't have the full total eclipse near you, you can observe the eclipse, and basically the sun is behind you, filtered through the tree, and you're looking at the ground, and hey, you'll get an image of the sun that works great. Don't have a tree near you. Some of my friends live out in the desert, and they're like, what's a tree? You can use other things. If you have a kitchen colander that you use to strain pasta, you can take a kitchen colander, hold it up in the sun, look down on the ground, and it will project dozens of solar images. Got a piece of pegboard with holes in it? Do you have a small thin piece of wood or paneling, and you can take, say, a 1/8 or 3/16 inch drill, basically a 3 millimeter drill, drill a bunch of holes in it, hold it up, and guess what? You'll get all kinds of little projections of the sun. So for families, for teachers, gee, I'm going to be in class during that time. Sure, take your kids out under a tree, take a kitchen colander out, drill some holes in a board. You know what? You could take cardboard and punch pencil-sized holes through the cardboard. Every child could have one, and when they're projecting this way, friends, the only way it works is if the sun is behind you, you're holding your cardboard, and it's projecting on the ground at your feet. The beauty of this method is, in order to see it, you have to be turned 180 degrees away from the sun. So if the kids are holding a board, a piece of cardboard with a hole, and you're like, there it is, projected on the ground. Look, kids. Well, you know what? When they're looking down here, the sun is back behind them, and they're perfectly safe. The other thing you can do, and this is lots of fun, if you have a pair of binoculars, cover up one of the lenses. Hold your binocular to where the front of the binocular is pointing towards the sun, And the image, again, will be projected down through your binocular, and you can project the image holding your binocular onto a piece of paper. If you've got science-oriented students in your home, this makes a great science fair project. You can go ahead and have a tablet of graph paper. You can clamp your binocular. Blue tape works on a tripod so that it's pointing at the sun, and you can take your pad and you can make sketches. And trust me, I was out with a binocular and a tripod, and I projected these images, and I sketched one every 5 minutes. And look at my whole panorama of images of the solar eclipse. This would be a winner at my high school when I was teaching. So great science fair activity. And if you're a homeschool parent, boom, I hope you'll be out there observing this stunning, amazing natural phenomenon with your students and children at home. There are really few times when we can actually look at and see in real time the dynamic solar system moving and in action in an easily visible way. This one, we can actually see the moon move in, cover the solar disk, and then move away in real time. And we can impress upon our students, wow, what's happening here? The moon in its orbit is crossing between the Earth and the sun, but the moon, why doesn't it last? Why doesn't it stay? Because the moon is always moving. It's moving in orbit. And so this is a transitory phenomena because everything in the solar system is in motion. Now, with that, please remember, observing your solar eclipse, one, safety first. This means safety for you, safety for your equipment. If you're a telescope observer and you've purchased the best solar filter money can buy and you're ready, do yourself a favor. If you have a finder scope on your telescope, take it off. If you can't easily take it off your telescope, put the caps on the ends of your finder scope. If you don't have caps, use a piece of tin foil and a rubber band. Why? Well, guess what? The sun's energy, your finder scope is designed so that it focuses the light on the crosshair. The crosshair sits in the plane of focus, and having worked for various telescope companies for many years, I can guarantee you after an eclipse, the repair department is going to get calls. Well, I went out for the eclipse and something happened. My finder scope isn't working anymore. The crosshair is gone. Yes, because you melted it. If you point your finder scope at the sun, guess what? You will melt the crosshairs. They're only very fine wire, or sometimes they may be even hair. I've seen astronomers that use hair because the crosshair needs to be nice and fine for precision, and you will ruin it. So make sure you do that. And friends, it's true. If you're going out to observe the eclipse as an astronomer, be a recluse. Don't take anyone with you. Setting up to observe the eclipse takes time, takes patience, takes precision. You've got to be ready because it's transitory. Totality may last only seconds, depending on where you are. So if you're not absolutely ready in all aspects, you're going to miss it. And if you have someone tugging at your sleeve, but wait, is that it? Can I see? Can I have a go? Wow, can I look? So you can observe an eclipse in two ways. You can be a citizen scientist, and you can observe that solar eclipse with your binocular, with your telescope, with your sketch pad, with your camera. You can be recording things like first contact, totality time, last contact, totality duration. All these things are scientifically useful and exciting. You can be taking these wonderful series of photographs that are just beautiful and amazing. Maybe you've set up to capture the eclipse with a dramatic foreground. Awesome. But you know what? If you're out with family and friends, you're the expert. I won't be there. You're the expert. You're the one. Well, Don't you watch Dr. Barth in that How Do You Know program? Don't you get all these astronomy magazines? Don't you own your own telescope? You're our expert. Help us see the eclipse. And that's a fine role to take, and it's very fulfilling. I love that. Every solar eclipse I've seen has been as a master observer helping others. But you've got to be content with that role. And if you take family members, especially friends, if you're taking children along with you, you must impress upon them beforehand. Safety, never look at the eclipse. And if you've got kids and even adults, you've got to be policing the observing area and making sure, don't look that way, hold it this way, look down here. Here's the safe way. You've got to teach people beforehand how to observe safely and make sure they observe the protocol.
Segue to your book.
Yes, a segue to my book. Star Mentor has sections on eclipses and solar observing. It has sections on how to observe safely and properly. So go ahead and take a look. If you haven't got one, pick up a copy of Star Mentor, available at fine bookstores, Amazon, and other online sellers. And please, if you do purchase the book, take the time, leave us a review, give us a like. That always helps. Help other people find this resource that you find so valuable. So that's all we have for you today. We'll be looking at more exciting science news in the world of astronomy and space science next week. And as always, if you have comments or questions, you're welcome to email me at astronomyforeducators@gmail.com. And if you have a show or a topic you'd like to see me cover, please drop me a line, because I love to get suggestions from our viewers, and your interest drives us to provide you with a better and more interesting show. That's all we have for you for this week, folks. Thanks very much, and tune in again next time.
Prepare for the solar eclipse on October 14th, 2023 with our exclusive solar viewing glasses. These glasses are not only designed to protect your eyes from the sun's rays, but they're also proudly made in the USA and meet the highest international standards. With comfortable temples and stylish black and gold design, you'll be all set to witness the eclipse in both safety and style. Experience the eclipse with confidence and embrace quality craftsmanship. Explore our solar viewing glasses now, proudly made in the USA for an unparalleled viewing experience.